Hello viewers and welcome to Engineers Mindset Academy. So in this video we are going to be considering this question to explain the concept of alternating voltage. Now the question says an alternating voltage is given by V of t equals 282.8 sine 314t volts. Find the root mean square voltage, the frequency, and instantaneous value of voltage when t is equal to 4 minutes. Alright, so we are given our voltage function to be this V of 2 equals 282.8 sine 314t. Now for an alternating voltage, our voltage function is given simply as V of t is equal to V peak sine omega t plus the phase angle. Okay, where omega simply means the angular frequency in radians per second and t simply means the instantaneous time, whereas this symbol is the symbol for the phase angle. Okay, so upon comparison, this simply implies that our peak voltage V peak is equal to, comparing these two, it means that our peak voltage is simply going to be equal to 282.8 volts. Okay, so this is our peak voltage upon comparison because this matches with this, and of course sine goes for sine. Then now in this case we are not given any phase angle because we just have 314t and we have omega t plus our phase angle, which means the value of the phase angle in this case is 0. So this also means upon comparison that our angular frequency is going to be equal to what? 314 in radian per second. Okay, so angular frequency is 314 in radians per seconds. But you can also convert the angular frequency to be in hertz, knowing fully well that our angular frequency is same thing as 2 pi f, where f stands for the frequency in hertz. So this simply implies that our frequency in hertz is simply the angular frequency all over 2 pi. So this is equal to 314 all over 2 times 3.142. This is 314 divided 2 times 3.142 gives us 6.284. Okay, so upon division we are going to obtain the value of our frequency in hertz to be equal to, so this gives our frequency to be approximately 500 in hertz. Alright, so you can have two values of the frequency either in hertz or in radian per seconds as obtained here earlier. So that's the second part of the question, which is asking us to calculate the frequency. Now the first part of the question says we should calculate the value of the root mean square voltage. Now take note, the root mean square voltage VRMS is simply equal to the value of the peak voltage divided by square root of 2. This is the formula to calculate the root mean square voltage. So let's take a look at our options again. Alright, so we obtained our peak voltage to be equal to 282.8 volts. Therefore, the root mean square voltage is simply going to be equal to 282.8 volts divided by root 2. Okay, this is actually 282.8 volts divided by, let's obtain the square root of 2. That gives us 1.4142. So this simply implies that our root mean square voltage is equal to, now let's find 282.8 divided by that answer, and that simply gives us approximately 200 volts. Okay, so this becomes our root mean square voltage. Now the next question says to find the value of the instantaneous voltage when t is equal to 4 minutes. Okay, so when t equals 4 minutes, next thing we do here is to convert this minutes to seconds. That means t is equal to 4 times 60 seconds, which is actually 240 seconds, and this is our time. Now, given the voltage function, V of t is equal to 282.8 sine omega t. Alright, so this simply means wherever you see t, put in the value as 240 seconds. That gives us the instantaneous voltage at that given time. Alright, so V of t becomes V of 240 seconds, and this is equal to 282.8 sine, we have 314 multiplies t, and t itself is 240. So this is equal to 282.8 sine. Now let's obtain 314 times 240. That gives us 75360. Okay. Now this is going to be equal to 282.8 multiplied by, let's obtain sine 75360. And the sign of that value simply gives us 0.8660. Alright, so having known this, this simply implies that the instantaneous voltage when the time is 240 seconds is simply going to be multiply this value by 282.8, and we obtain 244.9 volts. Alright, so this is the value of the instantaneous voltage. Alright guys, so that's it for that given question on alternating voltage. I will see you in the next video with another amazing question. Thanks.